Okay, we're going to go into hurricanes and tropical cyclones now. We've been dealing with mid-latitude weather. And what we're doing is shifting into the tropics. What defines tropics, you might ask? Well, it's anywhere basically the sun pretty much is going to get directly overhead at some point, and pretty much constant temperatures. They almost never have a frontal passage. And another aspect is the actual temperature change between night and day is more than the change from going from season to season. So we don't live in that climate up here. However, I want you to take a look at Milton here a minute. We're going to talk a little bit about hurricanes. Notice the dead center of this blob. This is when it was a category 5. It was very intense. It was right over the center here, little tiny blob. Having extreme convection, lots of thunderstorms basically. Tops were getting up very, very high. The winds at this moment were 180 miles per hour. Notice there's a band that goes like this out here and another one up here. There's a spiraling inward with these bands. A hurricane has several bands. So when a hurricane is approaching you, you may get one area of rain, stop. You may get another area of rain, stop. Finally, get the main. Highest winds are, most intense rain. And then, if you go through the eye, you'll start the process back over again, moving out of the eye into a new eye wall, very intense wind. Then it will weaken. So what I want also to take away from this is another aspect of hurricanes, with all this moisture coming out of the landing, warm water temperature, a tremendous amount of moisture available to these storms. So they pull it in from the environment where they develop. And as they're moving along, they bring the moisture with them. Sarah, that is occurring right now, has dumped upwards of 35 inches over Honduras. That is tropical moisture that was pulled into the system, which doesn't happen up here. Now, when these tropical systems move out of the tropics and come towards our latitude, they're bringing that tropical moisture with them. That's why when sometimes they hit the United States, we can get very, very heavy rainfall. In West Virginia and Virginia, actually, Camille, back in the 1970s, early 1970s actually, produced over 35 inches of rain overnight in some areas of eastern West Virginia and western Virginia. Some mountains totally slid down during that time. You used to be able to drive along Interstate 81 and actually see where those areas occurred. So that was all part of what a hurricane can do. Hurricanes can also produce tornadoes. There were numerous tornadoes during this storm. Over 40, some tornadoes actually occurred. The strongest one in EF3 in the eastern part. Where do they occur? Lands that are well outside, like this, away from the center. They don't typically occur in the center of a hurricane. Why is it they occur out there? Very strong winds, we know, hit the coast. Well, there's a wind on the top all the way up in a hurricane. So at the low levels, when the wind is hitting the coast, friction increases, as we have learned, and when it increases, it slows the wind at the surface. However, it's not slowing the wind aloft. That slowing of the wind at the surface initially causes a wind shear to develop, very strong wind shear at times. That, combined with the thunderstorms that are developing, aids in tornado development. So I wanted to just show you this all from one storm. Oh yeah, there's also the storm surge. Think about it. You have counterclockwise winds. So where is the storm surge going to be the strongest? If I have a storm coming from the Gulf of Mexico towards Florida, so they're moving from the west to the east, where is the storm surge going to be the strongest? Well, it's probably not going to be where I have an easterly wind blowing away from the coast of Florida. It's going to be where I have a westerly wind or southwest wind pushing into the coast of Florida. That's why very important to know exactly where the center of the storm is going to know whether you're going to have a very strong west wind or a very strong east wind, because they're going to be very close together around that eye. So that's why when Milton, some areas were going to get very bad storm surge and some areas weren't going to get any, and it depended very much. We're talking an eye that was about 5 miles across at this time. So literally the wind shifted maybe in 10 miles. So if you're off by 10 miles, if your home was 10 miles one direction and that happened to be north of the eye, yes, you're going to get very strong winds, but you're not going to get the storm surge flooding. By the same token, if that storm had been 10 miles further north, you'd had the very strong winds, but you would have also had the storm surge flooding. So now that we've covered the general basics of this, let's go to here, and we'll see if we can. All right. This is the definition of where the tropics are. You'll notice they basically consist in the areas that receive direct sunlight. No fronts really pass in this area. Also, hurricanes. I want to make sure we contrast. Understand that a hurricane gets its energy all from the ocean, from latent heat release from the ocean, and there's no temperature contrast. I showed you a storm this week where over 12 degrees Celsius temperature contrast occurred across literally about 100 miles. In a hurricane, you go 500 miles across it, and there's no temperature change. They're this very humid, very warm air mass. So understand that. That is why it's considered very different than extratropical cyclones. Also, when you're going up in a hurricane, remember it's a warm air mass. Temperatures, warm air means the pressure is going to decrease slower with height, so you actually wind up with a ridge over top of you. Whereas the extratropical storm I showed you this week had a very distinct cold, more intense low up aloft. This will actually turn into a ridge. You can see the eye wall here, and you can see how the winds are coming in spiral bands. Again, Milton had the classics with several spiral bands outward from it, moving inward until the most intense area around the eye and the eye wall. There's a couple things necessary. You need high temperatures, greater than 80 degrees, and that 80-degree water temperature must be at least 150 feet deep. And you need weak winds aloft. So in other words, if I have winds picking up and moving faster in the general atmosphere, not necessarily with the storm, that are trying to mess up the straight up and down convection. We talk about convection. We talked about it this week where you needed a wind shear. Well, exactly the opposite occurs in a hurricane. We want no wind shear. So we want weak winds. What happened with Milton as it approached the coast, there was a cold front to the north that was approaching. It helped to create some wind shear. That helped to weaken Milton. Also, we need really humid air all the way up, especially in the mid-troposphere. Well, when that cold front came down towards Milton, what did it have? It had drier air. So that's what weakened it. So all of these contribute to whether a hurricane will intensify or whether it will decrease. Also, you must have Coriolis effect. At the equator, there is no Coriolis effect. So that means lows can form, but they're not going to intensify into hurricanes down near the equator because there's no Coriolis effect. It can't create the right turn to the wind in the northern hemisphere that causes it to eventually go in a circle to make a low. With that warm water, we looked at these loop currents here in the Gulf of Mexico and all, or off the East Coast, where one of the interesting things about hurricanes is there's a Gulf Stream that flows up just off the East Coast of the United States. Sometimes the water is a little bit cooler further out over the Atlantic that these storms are moving across, and they actually intensify a little bit when they move across the Gulf streams. So that's why some hurricanes can actually come up offshore of the United States, stay over the Gulf Stream, continue to feed on that warm water, and get all the way into New England. So typically, on average, there's about 84, 85 storms, tropical cyclones that develop every year. Some in the North American basin, some in the in the Pacific. And here you can see where they kind of develop favorable regions. Notice the Atlantic is where the most likely they're going to hit the United States. The hurricanes that develop on the east side, on the west side, of Mexico, actually form and move towards the west. So they wind up not coming in and affecting the United States. They may hit parts of the very southern part of California sometimes have been hit, but the water's fairly cold there, so they're weakening. They may come up land a little bit into Mexico, which brings some moisture up, so some of the moisture can get into the United States, but not the real strong winds like we have with the hurricanes that strike the Gulf or the east coast of the United States. Most of hurricane season is peaks in September, late August, September into early October. Then it really begins to fall off. However, there have been hurricanes even in some of the wintertime months where they've developed out over the tropics. So hurricanes form, and notice I wanted to look at November here, or even into October, where most of the hurricanes kind of form in the Gulf of Mexico or down in the Caribbean Ocean and stuff, because that's the last area that gets cooler. There are different disturbances in the tropics. They're not like extratropical lows you see moving across or temperature changes like that. They're waves, and they're called easterly waves. They tend to propagate westward across the United States. Well, they do that and form these lows, these tropical cyclones. There's another thing called the Saharan air layer. Saharan air layer is just an air mass that has developed over the Sahara deserts and moves westward. When it moves westward, it carries the dust. It's also very, very hot. So think about it. That hot air is moving over. Maybe the water is warm, maybe 80, but that air is probably 90. So it's actually creating an inversion over the ocean. All of this wind shear develops with it. The dust keeps that air from cooling, from warming up down by the water. Everything, the dryness, it inhibits. If it comes in contact with the hurricane, it will tend to weaken it or destroy it. It'll also pretend many times to keep it from developing. So here are the three rankings. You start off with the tropical depression, which means winds must reach sustained winds of 23 miles per hour. Tropical storm begets name 39 mile an hour, hurricane 74 mile an hour. And as it weakens, it can go back down across this, the same system. Tropical depression must have winds that flow counterclockwise all around it. In other words, it can't have, all the winds are from the east or all the winds are from the west. No, it's got to have winds going in different directions. And you see the damage from these. Almost all deaths occur from flooding of some type. That is why if you live near the coast, it's recommended you don't stay in your home. Because if you do, odds are that if that storm surge hits your area, you may be the one of the casualties we wind up reporting. So I think that's all I need to really say here. Hope you got a little bit out of this, and let me know if you have any questions.